To create our practical circuit on the breadboard, we shall start with SW1. We can see from our schematical diagram that the left-hand side of SW1 is connected to R1, and R1 is connected to the positive rail. We shall create a link to connect this to the positive rail. Next is TR1, and we can see that the base of TR1 is connected to the right-hand side of SW1 through a link. SW2 is next. Once again, the right-hand side of SW2 is connected to the positive rail through R2. We follow this with TR2. The right-hand side of SW2 is connected to the base of TR2 through a link. We can see here that the emitter of both transistors is connected together, likewise with the collectors. The emitter is connected to the negative rail through a link. Next is the LED. This is connected through a further link to the collector of TR1 and TR2. The right-hand side of the LED is connected to R3 and through a link to the positive rail. This completes the practical circuit. Here we have connected the battery and current flows through R1 to SW1, which is currently off. On the breadboard, current flows through the positive top rail and through R1 to SW1, which is currently off. It continues to flow through R2 to SW2, which is also off. On the breadboard, current flows to SW2. Current continues through R3, but because both transistors are off, the circuit cannot be completed and the LED remains off. On the breadboard, current also continues through R3, and again, as both transistors are off, the LED remains off. So when the input is 0 and 0, the output is also 0. We reset the circuit and close SW1, then attach the battery again. Current can now flow to TR1 and turn it on. Similarly, on the breadboard. Current then continues through R2 and to SW2, which is still off. But now that TR1 is on, current can now flow through TR1, completing the circuit, and the LED is turned on. Again, the same happens on the breadboard. So when the input is 1 and 0, then the output is 1. Resetting the circuit and switching SW2 on. The current cannot flow through the base of TR1, so it remains off. However, it can flow to the base of TR2, causing TR2 to be turned on. And the circuit can be completed, and again the LED is turned on. So when the input is 0 and 1, the output is 1. Finally, when both switches are turned on, current can now flow to the base of TR1, turning it on. The same applies to the breadboard. Also, because SW2 is also on, TR2 is also turned on. Now a complete circuit can be made through either transistor and the LED is turned on. Therefore, when the input is 1 and 1, the output is 1.